In this video, we'll be making piecewise defined functions everywhere continuous. The problem that we'll be working with is to determine the value of b, which will make f of x continuous everywhere. The first function is a piecewise defined function. F of x is equal to 5x plus 3 if x is less than or equal to -1, and f of x is equal to -3x plus b if x is greater than -1. Now with the piecewise defined function, this information acts like a boundary. At -1, on the left side of -1, the function behaves like this, 5x plus 3. So we have a y-intercept of 3 and a slope of 5. But then on the right side of -1, the function behaves like this one. Now the thing is, what we need to do to make this continuous is at x equal -1, both functions must have the same y value. So at x equals -1, both expressions must have the same value. So that's easy enough to do. This top function, if we put -1 in here for x, we get 5 times -1 plus 3, and that value must be equal to the value we get here on the second expression when we sub in -1 for x. So the two expressions must be equal when x equals -1. So let's just do the math. 5 times -1 is -5. -3 times -1 is 3. Combining terms here, -5 plus 3 is -2. And subtract 3 from both sides. So these will cancel, and b is equal to a -5. So what this says then is on the side we have a slope of 5 and a y-intercept of 3. So y-intercept of 3 and a slope of 5. So it'll be going like this on the left side of that boundary. And then on the right side, we have -3x minus 5, since we found b to be equal to -5. So the y-intercept is -5, and the slope is -3. So we can go up 3 and left 1, and that line goes like that. Now this is everywhere continuous. On the left side we have a solid endpoint here on this ray, but on the right side it's for x is greater than -1, so that would be open, but it's still a continuous function. Let's look at another one. On this one we have 2 endpoints. At x equal 2, we have x squared equaling ax plus b, and then at x equal 5, we have ax plus b equaling 3x plus 1. So basically we'll be doing the same thing. We'll sub in our numbers. X equal 2 on this one gives me 2 squared is equal to a times 2 plus b. So 4 equals 2a plus b. And on this one, when x is 5, we have a times 5 plus b is equal to 3 times 5 plus 1. This one is 5a plus b is equal to, let's see, 15 plus 1 is 16. So basically what we have here is a system of two equations in two unknowns. 2a plus b is equal to 4 from this side, and then 5a plus b is equal to 16 from this side. I'm going to use elimination and eliminate the b's here, so I'll run a negative through this top equation and add the two equations together. Negative 2a plus 5a is 3a, and then negative b and positive b, those cancel off, and then equals negative 4 plus 16 is 12. Divide both sides by 3, and a is equal to 4. Now that we have a equals 4, we can put that back into either one of the equations. So let's go ahead and put it here. 4 is equal to 2 times a, but a is 4, plus b. 4 is equal to 8 plus b, and then subtract 8 from both sides, and negative 4 is b. So for our problem then, in order for this to be continuous, a is equal to 4 and b is equal to negative 4.